Hi, in this lecture we will simulate network failures between nodes, their effects, and recovery options. Let's imagine two nodes cluster. Node 1 and Node 2 are connected each other and they act as a single logical broker. When a network between them fails, then each node waits 60 seconds by default for its peer. After 60 seconds, Node 1 thinks that Node 2 went down, and Node 2 thinks that Node 1 went down. Both are thinking that the other one is down and they start acting separately. From this moment, queues, bindings, exchanges can be created or deleted separately. Situation is a classic split brain effect, and split brain effect causes network partitions. RabbitMQ cluster requires fast and reliable network, but even if you have it, you won't avoid split brain effect because it's a common situation in all distributed systems. Question is how you want to solve it. Network connection failures between nodes have an effect on data consistency and availability to client operations, as in the CAP theorem. Since different applications have different requirements around consistency and availability, RabbitMQ supports different partition handling strategies. Depends on chosen strategy, RabbitMQ can ignore them, waiting for human action, or try to fix them automatically. If you want to check if your cluster facing any partition issues, run RabbitMQ diagnostics cluster status or use RESTful API. No active partitions means everything is fine. Let's simulate split brain effect in a simple cluster with default partition handling strategy. Alright, this is my environment to simulate network partitions. Typically, you should run every node on a separate server. However, in this experiment, I'm using a 3 nodes cluster running on the same Windows server like in previous lectures. Simulating network issues on a single machine can be problematic. That's why I'm using a virtual machine for that reason. Before I run my virtual machine, I define 3 network interfaces, each for every node. Windows will automatically assign IP addresses to all of them. Let's check my network interfaces. To do this, I need to open a new command prompt. Okay. Here you see 3 network interfaces of my virtual machine. And in the command prompt, we see IP address, which is automatically assigned to every single interface. So this is the first one, second one, and third one. Every interface has its own IP address. Now we need to assign each of them to appropriate RabbitMQ node. RabbitMQ node names are defined by a prefix and hostname. In previous lectures, we ran 3 nodes on the same server by using different prefixes and the same hostname. Hostname should be a DNS resolved hostname like localhost in previous lectures. But here I define custom hostnames to be used as a part of my node names. For that reason, I added 3 lines in localhosts file, one for every node. Hosts file is located in C Windows System32 drivers etc folder. Node1.local is resolved as IP 10.0.2.15. Node2.local is resolved as IP 10.0.3.15, and Node3.local is resolved as IP 10.0.4.15. As you see, I disabled second interface, but I can still access second node using the localhost. Alright, I split my cluster. I had one logical broker, and now I have 2 of them. Both parts work separately. From the Node 1 and Node 3 perspective, Node 2 went down, but from the Node 2 perspective, Node 1 and Node 3 went down. From this moment, both parts of my cluster are acting separately. Queues, bindings, exchanges can be created or deleted separately. Let's create a simple exchange. In the management UI of the first node, so inside the first partition, I'm going to create a new exchange.